Hey guys, I need you to check this out. This is the new IGEMS software. I learned a new tool on the software. This software has proven to just basically be able to improve every aspect of my Waterjet cutting. And I would love to share it with you guys. So here's another tool that I learned that I'm going to share in this video. So as you can see from here, I have a couple parts that I want to essentially nest onto a 4x8 sheet. These parts, I always cut out of body metal, so 22 gauge carbon steel, or sometimes I do it out of 22 gauge stainless steel. So what these parts are for my rose kits that I make. So for those of you who have seen my video, I do have a video on those rose kits on our YouTube channel. Of how to make them, and they can be purchased on our website, or you can cut them out by hand with tin snips and follow along with the actual assembly video. So with these parts, I need to essentially make a nest. So I need to nest, let's say, 1,000 of these parts and 2,000 of these parts. So while I go to nest these two parts, the thing that drives me absolutely crazy with the Waterjet cutting is the dwell time. So the dwell time is when you're finished your cut, the Waterjet basically pauses for 3/4 of a second or half a second in order to ensure that it clears all the abrasive out of the mixing tube, which isn't a big deal when you're cutting thicker material because it spends a long time cutting and you want to make sure it clears out that abrasive. However, when you get onto thin material, the actual dwell time of this mixing tube clearing takes longer than the cutting process itself. So now you times that by 1,000 parts and it just doubled your time very easily. So I'm going to show you a tool utilizing the IGEMS software that is going to allow me to skip that whole step altogether. So essentially what it'll do is I'll be able to put one lead in on here, and it'll cut all 1,000 exterior cuts of the roses and all of the leaves, and then it'll do your lead out on the last part. And this is just for all exterior cuts, but it still saves a ton of time. And I will do a comparison in this video of how long it would take if I was doing it just with, let's say, Space Claim. I'm still going to use iGEMS to nest it because I don't have any nesting software for the Flow software, but I do within iGEMS. So I will show you that quick, and then we'll do a comparison between the two. So let's get started. So with iGEMS, it's super easy to create a nest. So I'm just going to select in my sheet 96 by 48, and it immediately makes a sheet for me. So that's a 4x8 sheet, 4 foot by 8 foot. I'm just going to nest right now. So what I'm going to do is I'm going to nest the two parts. So it tells me at the bottom of the screen to select the parts. So this is the parts that I want to nest. Hit enter, and then I'm going to select the actual sheet itself. So it tells you at the bottom here again, select sheets and obstacles. So if there was other cutouts in this sheet that I saved, it'll go around that as well, so you can utilize your scrap steel. All right, so now in this tab, like I said, I'm going to do about 2,000, and I'm going to do, so for every rose, it's actually 3 petals, 3 rows of petals. So essentially, I'm not sure if I'm going to be able to fit that, so let's just play with the numbers and see. We'll do 1,000 to start, and I'll do 3,000. Not sure that's actually, sorry, 2,000. Because for every 3 petals, I need 2 leaves. So if I do 1,000 and 2,000, that should work out. I'm not going to use common line cutting or anything like that. The distance, part distance in between, I have it selected by material, but you could do it like this as well. 0.06. Let's just say I want to be as close as possible to minimize scrap. So you see it very quickly fills that sheet up. So I am getting 631 parts total. So now we want to make sure that we're getting the right amount of leaves compared to the right amount of petals. So let's just go back in here. So we got 263 petals, and we got 315 of the, 315 of the petals of the leaves and 263 of the petals. So that doesn't really work because how many more I actually need. So let's just do some quick math. So if I could fit, I know I could fit 263. So if I have 263, and I could probably fit 265 just to keep it nice. Divide that by 3. That gives me 88 actual roses, which means we need times 2. We need 176 of the leaves. So let's do that. Keep our numbers right here, so we have them as a reference, or not. So 88 leaves. Let's try it for 89 and 176. 177 leaves. So if we do our math again to double check our work, we have 177, 265 divided by 3 is 88 roses. And for every single rose, we need 2 leaves. That's 2. Perfect. Let's re-nest that. So it tells you here how many parts we're getting out of it. The longer you wait, the longer it will improve. This is already a pretty tight amount. So what I'm going to do here is I'm going to stop this. So we're missing about, let's say 13 of our petals. But look at this. So I actually messed up on that one. When I re-nested it, I forgot to select this guy. 0.06 is my distance between parts. Okay. So what I'm going to do this time is I'm going to make it fill the rest of the space up with leaves, just so we have extra, because why not? We got this, we did everything. One other thing I do like about this software is that anytime I can get a report. So I can select this, get my report, and it'll tell me how many of each part I have. Now, in this case, it's just 2 different parts, right? So it'll tell me the difference between each part, and it does it as a Word document, so I don't have to worry about anything too crazy. I can add instructions from this. There's a lot I could do with it. So, 1 sheet, 460 parts total. I could actually label these parts in the in IGEMS, but that's for another time. So I'm getting 263 of the petals, which is going to give me 263 divided by 3, 87 and a half, or 87 and 5/8. But it'll give me 87 roses. So if I have 87 roses times 2, I need 175 petals. How many petals, or leaves, sorry. How many leaves am I getting? I am getting 197. So I will be good. It's not a bad thing having extra leaves. Sometimes they you mess up when you're chiseling them, things like that. But all of this stuff is wrong because I haven't set it up, because I'm only using IGEMS currently to nest to show you guys the difference. So I couldn't believe the difference on this, but it was quite impressive. So I'm just going to close this down for right now. I am going to re-nest this one more time just to try. What was our number? 170. 177. So 265. I know that I'm going to end up missing one part, but regardless, we'll play with it, play along. 0.6. And the reason I'm doing 0.6 is the mixing tube I use is 0.04. That'll be lots of room to cut into the scrap. It might cut into the scrap in the same spot more than once, but I'm okay with that. This is just for testing purposes for right now. So as it goes through, you can watch the numbers, the fill ratio. This all changes. So the more it fits and the more it nests, the more parts it's going to actually fit on the sheet. And you can go back through all the other ones to see if you liked those nests better. Sometimes it's all about cleanliness, but let's just see where we're at. So, we're pretty damn close. We've almost fit all of them in there. So it just goes to show you, sometimes you could be a little bit more patient, and yeah, it will utilize all of your space and get all your parts that you need. So I'm going to just accept it there. I'm okay with that. Yep, boom. Let's move forward. So utilizing this as our nest, I am going to now save as. I'm going to export it. I'm going to deselect this because I don't need it as a DXF file. So these are my roses. I'm going to put roses nested for, I'm just going to call it 85 roses just to keep it consistent. Now I'm going to pull up my Flow Infinity software. So I'm just going to import this DXF. Products, roses, 85. Boom. Let's open this bad boy up. Okay, so here you see all of our nested parts. So you can use this software in order to nest your parts on your own software as well. Keep in mind too, you can do the same thing with plasma cutting as well. You just got to know your parameters a little bit better. IGEMS is designed mainly for waterjet cutting, but they have been jumping into the plasma cutting market to help other companies with their nesting and optimization needs. So I'm just going to orientate this properly, which in this case, I just want it all squared with the table. With that, let's just go to sequence. We'll path all these parts and see how long it'll take to cut after it's pathed. So I'm just going to zoom in, make sure it's getting everything I want, which it is. Those holes are very small. They're only 1/8 holes for TIG wire. Obviously, the software is taking a minute because it is a lot of parts, and this software isn't ideal for nesting. So when you have a lot of the same parts, you're better off just kind of nesting it in the actual flow cut software, which would be the actual cut software down here. So this is the actual cut software, but we're going to go to that in a minute. All right, so there you have it. We have all of our parts nested. Let's just zoom in quick. Oop, whoa, not that far. Too far, too far. Okay, so there is an issue with our drawing. Lovely. So see how all of these guys are cutting on the outside? That means there's something wrong with the outside geometry. Well, after playing around for way too long in the Flow Infinity software, I decided to go back to iGEMS and see what the heck was wrong with my drawing. And I did find the issues, which was a perfect opportunity to show you the Analyze tool. So the cool thing about this Analyze tool is you can deselect it or select it at any time. Select the parts you want to analyze, as you can see here. And then when I find all my issues, like it's about to show me, I can go and adjust my cleanup tool to do the work for me. So as you can see, you click the cleanup tool. It'll ask you the tolerance you want for your cleanup. And basically you just select everything you want to clean up. And it works amazing almost every single time. I mean, there's times where you don't want to adjust a certain part of your drawing, but in this case, it worked flawlessly. So it's saying that I have no errors any longer. Let's take a look and make sure it didn't distort anything on us. Everything looks good. Okay. Now let's try this again. Okay, so we'll do it one more time. Analyze one last time just to double check everything. You never know. Sometimes it's a little overwhelming. I don't want whatever this is. Okay, no errors found. Perfect. Let's export this again. Delete that whole other atrocious file that I have here. So we'll save over it. Boom, boom, boom. Go back to here. Delete this whole file because that was something else. Do not save it. All right, now let's open that DXF file again. Sorry about that, guys, but it was a good opportunity to show you how powerful that analyzing tool and cleanup tool actually is on IGEMS. If you couldn't tell, I really like the IGEMS software. Okay, so I am going to orientate it again. Boom, put that back so it's square with the table. In iGEMS, the cool thing about that is you don't actually need this. It just automatically figures out where the corner of your sheet is by using the nesting feature. So let's try this again. Please, no errors. Fingers crossed. The funny thing is I'm only showing you guys this part of the process, which isn't normally part of the process. The only reason I'm showing you guys this is because I want to show you that you can still use iGEMS to nest if you still want to utilize your software for the next post procedure. All right, so the colors are looking good now. Boom, there we go. Now it's all fixed. Okay, so my mistake. I should have used the tools I had in front of me, but I did not. So everything looks good. Let's just export this as an ORD file. That's the files that my Waterjet uses for cutting purposes. I'm going to do it as a 2D file. I'm going to call it roses nested for 85. Boom. It's not a DXF, so I don't want to save it. Okay, so let's see how long this will take to cut 85 roses and the equivalent amount of leaves. Okay, I'm going to go back to my products. This is how I organize all my stuff on here is I go customers and products. This is a product that we sell, so I'm going to go to my products, find it. I don't want to save the previous one. I'm going to set this up for mild steel. 0.022, so it's going to make it 0.03 because that's like the minimum it says it can cut. It's not actually the minimum it can cut, it just software-wise, it's like as fast as it'll cut anyway, so it doesn't make a difference. This is set up properly. This 0.01, 0.04 is what I'm actually running. This is the abrasive off dwell time I was talking about. So this is what's going to add a lot of that time to this cut. But I'll show you with iGEMS how we can solve that. Yeah, see here, this is what I was talking about. Let's see how long this will take to cut out of a 4x8 sheet of body metal mild steel carbon. Mild carbon steel, sorry. So 280 minutes almost. So 278. So let's write that down. 278 minutes and 25 seconds. Number of entities. It's going to use 240 pounds roughly of abrasive, which is, I think each bag is about 55 pounds, 60 pounds, something like that. And the amount of number on off cycles is 703. So when we go to here, every single dwell time on and dwell time off is going to be added on to that 703. So see how much time that actually adds. Now check out what we're about to do. So now we're going to go back to iGEMS. We're going to do the same thing. So we're actually going to undo the things that we just did. Actually, nah, we better keep it the same. Maybe it won't let me. Okay, so what I'm going to do before anything is I'm going to, not to the sheet, I'm going to deselect the sheet, explode these, fix these with the Analyze tool. Real quick. And then, so there you go. You can see all the issues. If you had to do this manually too, you would be able to see. So see the little issues in my drawing. This is an old plasma drawing I had, so the software wasn't quite as good on my plasma as it is on the Waterjet. It catches every little thing, so I'm going to correct that right now. So now that it's done the cleanup tool, we can analyze it again. Wait for this to load and see if there's anything else that needs to be corrected. It is a super efficient and quick tool. Imagine going through every single one of these 265 pedals. Okay, we're good now. Now we are going to create a CAM file again because unfortunately we didn't have one before because we had to delete it. So we're just going to not have that on. Turn this off, and let's see what we're left with. So what I'm doing here is basically starting with all of my holes, and now I'm doing the bridge, and essentially how I'm doing that is I'm making the bridge width as small as I feel like making it, because it does not matter. I'm not trying to make it a grid so that when I pull it all apart, I just snap them off. I actually want them to fully cut out. So I know if I make it somewhere along the lines of being underneath my mixing tube diameter, then I know that it'll cut it out completely. Select all my parts. Now what it's going to do is it's going to create an extremely awesome cut path without having a whole bunch of start and stops and lead ins and lead outs. It's going to have one lead in, one lead out after cutting the full 4x8 sheet of rose petals. So, all right, let's see what we got. So we'll start at let's find the lead in. Where's the very beginning? So you can see how all these parts are actually connected with those little bridges like we talked about. So essentially what's going to happen now, I'm going to turn the snap off for a sec. My orifice is 0.03 or 0.04 depending on which one I use. That is going to come along the center of this, and then the center of this. So we should be okay, but you know what? Just for fun, I'm going to adjust that. So I'll undo it. We'll redo that one. Bridges. Let's try 0.001. Let's see what we're left with. Oh, actually, let's keep that there. I didn't realize this was on no compensation. And there we go. So now let's go and check that again. Like we said, no compensation, 0.03. There we go. So I believe that will go on the inside now, which is honestly okay. It's not going to affect my design. Just be careful. Depending on what you're doing, this might affect your design, but for me, works out good. All right, let's find that first lead in just so I could show you guys. All right, so there's the first lead. So when we actually go to process this, it's pretty neat how it works. Process, we'll do just a quick example here. So it's going to go through here. I'll just slow this down a little bit. So right now it's doing all of the holes. So now you can see, I'm actually just going to back that up just a little bit. So you can see where it's starting to cut. And it just keeps on cutting. Like, how crazy is that? Now, the real crazy part is I wonder how much time it's actually going to save us. So let's figure that out. We'll save this as an ORD, 0.03. Actually, yeah. Let's do this to 0.04. Just like we did in the last one. Products. Okay, so now we're going to do the same thing. We're going to import with bridging. 85 roses with bridging. Set it all up the exact same. The only thing is when you're using IGEMS, you do set up this guy a little bit differently, but that's an explanation for another video. So you will see that I am setting this part up a little differently. And 0.001. This has nothing to do with the time because all the time and all that stuff is adjusted regardless in IGEMS. 0.022, like we said, it's going to go back to 0.03. That's okay. All this will get automatically adjusted. 0.04. 0.1 or 1. Okay, turn this off. All right. Let's see here. Like we talked about, went to 0.03. That's okay. What are we left with time? So remembering that the last time estimate we got was 250 minutes and 28 seconds. What did this new nesting with the bridging give us? I'll go back. Estimated time, look at that, guys. 165 minutes and 20 seconds as compared to 250 minutes and 28 seconds. The amount of on-off cycles, a fraction. I believe it was like 700. We got 263 on-off cycles. That is insane. We're using a fraction of the abrasive used. Our cost estimate is down, even though that's not actually what it is. But look at that, guys. That is insane. IGEMS software for the win. That is incredible. And that's only breaching the surface of what this software is capable of. I've already been playing with this software for about a month and a half, 2 months now. And it is insane how much I have learned and how much I could do with that software. It is just incredible. I can't wait to see what else they come out with. I haven't really even played around with the 3D capabilities yet, but I know that in some of the training I did, the actual 3D 5X, which is their kind of 3D CAM software. So it's really only for tool pathing and stuff like that. You wouldn't really design in that software, at least not yet. I have a feeling that they're going to come out with something and make the actual 3D design software amazing as well. But guys, you can't beat this. That is insane how much time and money I am saving. And if you're charging that out to a customer, let's say you have your Waterjet, you're selling it as $200 an hour, you just saved that customer and probably got the job because of it. So 200, and this is just like, you know, standard rate, $200 an hour. Usually you have some expenditures for material storage or loading and unloading the table or whatever it may be, depending on how you want the parts after they're off the table. But a lot of the times customers are really happy with the finished product of Waterjet cutting. But check this out. So $200 times, sorry, actually, let me do this a little bit different. This is how I do it. 250 minutes and 28 seconds divided by 60. That gives us our hours times $200 an hour. That gives us $834. Let's just write this down. $834.27. We'll round up. And now our most up-to-date cost is 165 minutes. So let's compare that now. And once again, like I said, these are just the standard numbers that are here. This doesn't include anything like material handling or anything like that. If it's a weird material, it takes an hour to load. But let's just say, what's the exact number here? 165 minutes and 20 seconds. 165.20 divided by 60 times 200. Oops, $550. Oh, wow. Okay, so $550.67. The difference between those two is $834.27 minus $550.67. The difference is $283.60. So you just saved the customer just shy of $300 by using nothing but software. Now, imagine if this was just software that you were buying to improve your efficiency and your shop production. That is a lot of money to save on body metal cutting, guys. Come on. That's insane. It went from being, you know, four hours to 2 and almost 3 hours, but still, you're saving over an hour on cutting body metal. Like, that's insane. I don't know. I can't speak highly enough of this software. I can't believe the stuff that it's capable of doing. And once again, this is barely breaching the surface, but I am super excited to see what else I can do with this software. Thanks for watching, guys. I hope this video was helpful. IGEMS, huge shout out to you guys. This software has been the best decision I have ever made. Thank you so much, and thank you for watching. If you guys haven't already subscribed, please do so now, and ring that little bell to make sure that you get notified when our next videos come out. More to come on the Waterjet cutting. See you guys later.